Okay, so hello everyone. Today I'm going to discuss code forces round 1051. Problem A. So we are given all lengths. Okay, don't need to read the question. So we are given permutation P, and we can perform exactly one operation for each integer K. Okay, I hope that you have read the question. So we have to output yes if it is possible to make all elements of the array P equal to 0. And uh, how can we perform the operation? We have to subtract 1 from every element in the sub-array of length exactly k. And we have to make all the elements of the permutation p equal to 0. Okay, so for example, let's suppose this case. So I want all the value to be 0. 1 should be 0, this 3 should be 0, they all must be 0. So how can we do it? Okay, let me share my whiteboard. Okay, I hope my whiteboard is visible. So let's consider this case 1, 3, 4, 2. So my first question is that if you want to make 0, 0, 0, 0, all of them equal to 0, and you can reduce only if you have a sub-array of length k, so you can reduce all the elements by 1 in that subarray of size k. And other thing is that you can choose this length k only once, so you won't get any other chance to do this. So how can you perform? So the first approach that got into my mind is that I know that I cannot choose the first subarray. Like if I choose 1, 3, 4, 2, then it will become 0, 2, 3, 1. Okay. Now, if I choose this 2 and 3, it will become 1, 2, 1. Now, if I choose this 2, it will become 1. Now we are left with 1, 1, 1, 0, and we will choose this, and it will become 0, 0, 0, 0. Okay. So this way we will get all the elements as 0. But uh, did you notice one thing? That if you want to reduce uh, a sub array of length 1, okay, let's say length 1, the sub array length is 1, that is k is equal to 1. So if you choose 3 here, 3 in this case, like 1, 3, 4, 2. So if you choose this, so it will become 1, 2, 4, 2. Okay. Now you will have to reduce this 4 by 2. And how can you do it? My question is, how can you do this? If you reduce this by 2, you can do either this one, you choose these two. So 1, 1, 3, 2, and then you choose these two. It will become 1, 1, 2, 1. Now, what you will choose? All of them will become 0, but this will remain 1. Do you have any other option? What you can do? So, what logic came to my mind? I will choose the largest number, which is n. Of course, it's a permutation, so the largest number is n. Okay. Now I will choose its adjacent element. Okay. I will first reduce n by 1. So it will become n minus 1. Then I will choose its adjacent element. It should be n minus 1. Or this element, it should be n minus 1. If they both are not n minus 1, then simply my answer is no. Because then how can you make them equal? My logic is that you want to make all the elements of the array equal slowly and gradually. Okay, like let's consider the second test case 15243. 15243. Okay, so you want this 5 to become 0. Okay, but before 0 you want it to become 4. Okay, you want it to become 4 before 0. Okay, so how it can become 4? You will reduce it by 1, but if you reduce it by 1, okay, then if 4 is like not adjacent to this 5, then you cannot group these two 4 together and together make them 3. Okay, you know what I'm saying? Like if this 4 was adjacent to 5, then I would simply reduce these two 4 together and they both could become 3. And then if we find any adjacent element, uh, like 3 must be here or here, then I will reduce all these 3 together. So I think you got the logic. And I will take another test case 24531. 24531, and then you will be clear what I'm saying. So first I will keep a left pointer and a right pointer. Okay, and they both must be equal to n, like the index where n is there. So let's say I, and at I, v of I is equal to n. Okay, then this is my left and this is my right, both are here. Now I will check adjacent elements. If any of the adjacent element is uh, n minus 1. Okay, and let's say that I will also take a variable target, and initially target value will be n minus 1. So I will just say, uh, I will just check if either left side of the left or right side of the right pointer, they are target. Okay, if they are target, then I will reduce my target because now I need 3. Okay, and if I got my target before the L pointer, then I will decrease my L pointer. And if I get my target after this L pointer, then I will increase my right pointer. Okay. So now this is my current array. Okay. And now they both are 4, 4. Okay. Now my target is 3. Okay. And my length, my left pointer decreased. Now I want a 3. So first I will check if before left there is 3, no, but after right there is. So now this will increase, and this both 4 will decrease by 1. So 3, 3, 3. Okay, so we are actually, increasing our space, and these are the condition which will help us to do this. Okay, so this was the logic. Now let's go to the code part. Mm. Okay, so this is the code. So of course, first we will input our vector, and yeah. So if n equals 1, then yeah, the answer is yes. Of course, we can reduce it to 0. And if it's not, then this is my index. I want to find the index I, where vi is equal to n. So index of maximum value, I will find that. And then my left and right pointer is at I, index I. Okay. My target is n minus 1, and this is my okay variable, which will check if everything is fine. Okay. When we are increasing our space, it will ensure that everything is fine. So while target is greater or equal to 1, because we don't want to find 0. Okay, because 0 is not in the permutation. Now first we will check if there is any target before left, but before that we will also check if it's greater or equal to 0. Okay, so these two conditions, then we will check in the right side, and also we will check if they're not, exceeding the index, in order to uh, stop the segmentation fault. And then we will check if it's equal to the target, we will increase the right pointer. And if both cases fails, then we are sure that in our space we cannot reduce more. We will not get any adjacent, will not get our target in the adjacent elements. So OK is equal to false. And yeah, if we didn't hit the else case, then we will reduce our target, and then this will go up till it's equal, greater or equal to 1. Now we just print the answer. So that was all for problem A. Now in the next video I will discuss problem B.